All right, class. This is part 3 of the April 13 series of videos. And last time we were rushing through merge sort, so let's revisit merge sort. And we are looking at the merge sort in the middle there, okay? And the merge, which is the helper function, we will come to it later. Okay, so merge sort XS is our list given to us, which is a list of integers. So we've gone back to specific rather than generics right now. We will actually make a generic version of this later. Okay, but XS is a list of integers now. Okay, and then the output is a list of integers, sorted version. Okay, and we need to start a block here because merge sort, if you recall, the way it works is that you split the list XS into 2, exactly right in the middle. Okay, if there are 10 items, 5 items and 5 items. Okay, or if there are 20, then 10 and 10. Okay, so the first 10 and the next 10. So you have to split exactly halfway. Okay, the list, and that's and the reason we have the block here, the block which begins with this brace. Okay, and ends there, is because we have 2 expressions here. Okay, one which is that, and the other one is which is this. Okay, so the first one is val n equals xs dot length by 2. Okay, so this will get you the half of the length of the list. Okay, and if n equals 0, it means that the list was either an empty list or a one item list, singleton. Correct. The reason is that 1 divided by 2 is also 0. Okay, this is integer division. So if it's a one item list or a 0 item list, the answer is the same list, right? There's nothing to sort there. Okay, so XS is the answer. Else would mean that we have 2 or more items. Okay, and we already know what the split is. The split point is n is given to us. Okay, or we calculated that. Okay, so I guess you could have simplified this by just replacing n by xs dot length by 2, and then you would not have needed the block. Okay, it's fine, either way is fine. Okay, and is that okay? So if you have 2 or more items in the list, then again we start another block because we had to split this and get the 2 pieces, and then we had to do some working on that, right? So we have a block, another block with two expressions. Okay, so the first expression here is take xs and split at, it's actually a function or a method available with lists. Given an index, it'll split it into 2 parts. Everything before that index, it'll make 1 part, and then everything including that index and beyond will be the second part. Okay, so it's a nice way of splitting in merge sort. Okay, and what you get back is a tuple. Okay, and we have not learned tuple yet, but we're going to learn it towards the end of it. You can think of tuple as a list. Well, basically a list, but except that there's a different. Yeah, I think the one thing you can have in a tuple is you can have non-homogeneous items. So that's how tuples differ from lists. Okay, but in this case it's homogeneous. Okay, so it doesn't mean you have to have non-homogeneous items. Okay. Anyway, the first variable here would be the first half of that list, and second variable here would be the second half of that list XS. Okay. And if you recall your merge sort algorithm from long time back, whenever you studied it, merge sort of first will sort the first list, right? So that's the sorted version of first. And this would be the sorted version of the second. Okay, so you have 2 sorted versions of the first and the second, and then you have 2 sorted lists, and then you merge them. Okay, and this merge can be done in O of n complexity, because you can set up pointers or whatever right from the beginning, and then start forming the new list by advancing these pointers. You see, so the merge, and merge of course is written above, and there's a second version of merge. Okay, so that's all there is in merge sort. Okay, so we are going to make use of merge function. Okay, so let's look at merge, which is above. Okay, so xs and ys are given to us, and we'll assume obviously that these 2 are sorted. Okay, because we'll never get to merge unless these 2 are sorted. Okay, and the return is a merged version of these 2. Okay, So now we have two lists, right, XS and YS. Remember in the concat example also we had XS and YS. There we got away with doing a match with just one of them, okay? But here I think we had to do match with both of them because you had to see whether XS is empty or not and whether YS is empty or not. So it's a really nested if then else kind of thing. So let's do it with a match. So XS match, okay, at the top level first. We decided to do with XS and nil and not nil, right? So those are the two cases. So here I say x colon xt. I don't say xs because xs is a variable already used there, okay? So that's why xt for xtail, okay? So these are the two cases, empty case and non-empty case. Now, if it's an empty case, if xs was empty, what will be the merge of these two, xs and ys? It'll be just ys, right? Because we got done with xs. Only ys is left, so ys will be the answer, okay? If it is not empty, then we get into the answer would be this expression, which is the two cases we are going to consider for ys, okay? Ys match, and again we have a nil and a yt here, okay? Y colon yt, okay? So this is technically a nested if then else, nested. It gets very complicated with the if then else. That's why we use the match and the cases and matches, okay? So now ys is going to match with one of these, nil or not nil, right? Nil, if ys is nil, and you can see that we are already in the case when xs is not nil, correct? So we are already, this case is when xs is not nil, because if xs was nil, we are already done way up there, okay? So when we say ys is nil here, in this case, it means that xs is not nil and ys is nil, all right? Because we are inside this case here. In that case, what is the answer? It will be xs, right? Because you have a not nil list, xs, and then the ys is nil, and if you want to merge these two sorted lists, it will just be xs, okay? But if ys is also not nil, okay? So now we have a case, this fourth case, see, case 1, case 2, case 3, case 4, okay? So case 4 is the situation when xs is not nil and ys is not nil, okay? So both of them are non-empty, okay? What do you do in this case? We already have extracted the head and the tails of these two lists, right? X is the head of the xs, y is the head of the ys, xt is the tail, and yt is the tail, right? So we already extracted those four using the patterns, okay? So this will be the answer, final answer here, okay? If in this case, okay? In this case, both of them are non-empty, then what do? You compare the first item, right? In xs with the first item in ys. If you recall the merge, that's how you do, okay? So if x is less than y, what does it mean? It means that x must be in the front of the final answer, right? Because xs is sorted, ys is sorted, so x is the smallest in xs, y is the smallest in ys, and x is less than y, which means x is the smallest in the whole combined list, correct? So that's why you put x in the front, x colon colon, and you recursively solve the rest of the merging, okay? Now in this case, since x has already been accounted for, you have to merge xt and ys, okay? Else, y is the smallest, so you put y in front of the final answer, and then merge xs with yt, right? Because y has already been accounted for, so and that's it. Okay, so this is the recursive version of the while loop solution you probably studied earlier. Okay, remember you'll have a while loop as long as both the lists are non-empty. Okay, and that's what is happening here and here. Okay, the recurse basically go to the next step. See, you advance the pointer in x or in y. Okay, and depending on x or y, which is less. Okay, and then keep going until you get one of them nil, and once you get one of them nil, you would have to empty out the rest of the list in the answer, right? And that happens in the other two cases. Okay, so it's nicely, beautifully structured here. So that's a merge solution, and we are done. Okay, now this since we had double matches, okay, xs match and ys match, there's a little bit cleaner way to do this. Okay, and here is merge 2, which does that. Okay, so the only way this is different is that here we have we combine XS and YS into a tuple. Okay, so tuple, that's how you do it. Parenthesis, some item, comma, some item, parenthesis is a tuple of 2 items. Okay, tuple. And since XS and YS are just variables, you can do a match, and because both of them are lists, so you can actually provide patterns which are a little bit more generic than what we had here. Okay, so and actually we had only 3 cases there, right? One was that XS was nil, YS was possibly not nil. Okay, so that would be this case. Okay, other cases, YS is nil, XS is not nil. That's this case, and in both the cases the answer will be YS or XS. You see, so that's easy to see how to merge in if either of the two is okay. And the third case is neither of them are null. Okay, got it? That means one item X at least and the one item Y at least. Okay, and in this case we actually have the code: if X is less than Y, then you. This is the same code as from earlier. Okay, but this looks a little bit more cleaner. Okay, right? I would line these arrows up so it looks a little better there. Okay, got it? Now, XS YS match technically should give us 4 possibilities, right? 4 possibilities, 4 different possibilities, whether they're nil or not. XS is nil, XS is not nil. YS is nil, YS is not nil. So there are 2 possibilities for each, and that should give us 4 possibilities. But you notice we have written only 3 possibilities here. Okay, we have not written the nil possibility. Okay, correct? Now, interestingly enough, the nil possibility is actually covered by 2. This case as well as that case, right? Because when you say nil comma YS, YS is just a variable. It can match nil, right? And similarly on the second one, XS can match nil. So we really have 2 cases here for nil. Again, going back to the original observation last time I made, you should try to make these cases mutually exclusive. That is, no overlaps. Okay. And last time we fixed it with overlap. Here, if we had to fix the overlaps, okay, it'll be like this. Okay, so I have the special case for nil, and then this one, YS will become Y colon YT. Okay, and this will become X colon XT. Okay, now we have the 4 cases which are completely mutually exclusive. Okay, and this answer would have to change. Actually, probably not, because YS is the same as Y colon YT. So this answer can stay the same. So this YS is same as Y colon YT. Correct? Right? Because YS is matching this, so you can actually say YS there. Okay. And similarly for XS here and then that. Okay. Now you see the 4 cases here. Okay, they're all mutually exclusive. That is, there's no possibility for X and YS which falls in more than one case. Okay, if both are empty, the first case. Okay, if X is empty, XS is empty, and YS is not empty, the second case. If XS is not empty, YS is empty, the third case. If both of them are not empty, the fourth case. Okay, so this cleans it out nicely. I somehow prefer mutually exclusive. See, I'm sort of paranoid programmer. I don't know if you have noticed that or not. Okay, I'm a little bit paranoid. So this is one thing, because now we don't depend on Scala's behavior on how it executes the cases. You see, right? I mean, if you understand how Scala executes, then maybe the previous solution is fine too. Okay. But this solution, the one with all the 4 cases spelled out nicely, okay, is foolproof. We don't depend on Scala's behavior, okay, because we have 4 cases, and these are the 4 different cases, and foolproof. So it would work no matter how Scala goes about doing these, okay, right? That's the idea behind the case here, okay. So try to make them mutually exclusive. Okay, now most of the time you should be able to do it. Okay, but occasionally there'll be some cases where it'll be difficult or tricky to do that. So that's why you may have to learn how Scala works on this. And I think the rule is it works beginning to the end. It probably does first case first, and if it satisfies, it gives that answer and stops. Okay, if not, it goes tries the second case, and the third case and the fourth case. So in that sense, you probably want to put these in the recursive case at the end and the non-recursive case in the beginning. Okay, got it? By the way, there's another sort of indentation, not rule, because here there's no indentation, doesn't matter. When you have this if then else expressions, okay, you'll see I'm writing it like this, but if you want to cleanly write it, see, you'll write it like that and indent it like this, two spaces here. You see that? So if condition, then go to the next line and just after the F, start the expression for this, else, and then write the expression for that. That looks much cleaner, although, I mean, just to conserve lines, you can do that, and even here, you could do that, okay? Or if you want to conserve one more line, you could do that, okay? And actually, in this case, because it fits, I prefer that, okay? Now it looks much cleaner, okay? Got it? By the way, notice that this if is green and this else is green because of the keywords. There is no then keyword, okay? Unfortunately, okay? If then else, okay? So that may have confused some of you a little bit, but that's Scala, okay? So there's no then there, okay? Okay, and you can run this if you want. Now this one calls only merge, but you may want to call merge 2 here and then try to figure out whether it still does the merge sort on that or not, okay? It does sort it there, okay? Now let's go to the next small fix to the previous merge sort, and that is the last one was written for a specific type of list, right? List of integers, correct? And that's fine if you're going to deal with integers. But if you want to write a more generic merge sort, which will work on any list of, or list of any type, list of integers, list of strings, and so on, we can try to solve that. Okay, so that's what this is. See, how to make merge sort more general. This is what we want to do. Okay, we want to define a function merge sort, which is generic, and typically when we say generic, if there's one or more types, in this case there's only one type, so we'll specify that after the function name, and then we will provide the parameters and use the t in the parameters. Okay, xs is a list of t, and then the output is a list of t, and equals, and this is what we want to write. Okay, so we want to write the code here. Okay, so we want to make it more general so that the same merge sort will work for strings, for doubles, for this or that, for whatever else. Okay, now the previous version obviously will not work because in the previous version, if you look at it, here it is, okay? Actually, there's only one part, which is in this part here, okay? In the merge, there was a x less than y comparison, okay? That's the only place where numbers are compared, by the way. There's no other place in the whole merge sort comparison happens, okay? So that's the only place, x less than y, okay? Now, less than is defined for integers, is probably defined for strings, and also probably defined for double and so on. So you may be able to, you still have to go and change this int to string or to double, many places, not just one place, you see. So it's a cumbersome, right? So the idea is we want to write a generic function, okay? Merge sort for any t, okay? And of course, we have to worry about this compare because that's where two elements are compared in this list, okay? And the comparison of objects can happen differently, right? So for example, if you want to sort a list of student objects, okay? Student objects. So there is an object-oriented programming, okay? Or a list of students, okay? And each student object has, let's say, a GPA, okay? And I wanted, or exam scores, let's say, midterm or final exam scores, okay? And I wanted sorted, okay? I want to sort the students based on the score, okay? So the less than student, S1 and S2, let's say those are two objects, S1 less than S2 will not work, right? Because S1 is an object, S2 is an object, okay? So we may have to provide the less than comparison somehow as a parameter, okay? So that's where the higher order functions come in, okay? So there's function programming, you see this, so so we have to send the comparison operator, oops, yeah, we have to send the comparison, once again, okay, I think instead of double clicking, I should just do that, okay? Yeah, we have to send the comparison operator as a parameter into the merge sort and into the merge. Actually, technically only into the merge and not into the merge sort because merge sort does not compare, only merge compares, right? So we had to set this into that. Okay. So here's that version. Okay. Yeah. Actually, this is the final solution. Okay. So let's look at this solution now. Okay. This one is generic. So this will sort a list of any type. Okay. Def, merge, sort, and this is the template or a parameterized function. Okay. T could be any type. Access colon list T. So this is our list which we want to sort. Okay. And we are providing an additional parameter. Okay. By the way, we're not doing the comma, but we are doing curried second parameter. Okay. So if you remember from one of the earlier lectures, in functional programming, lambda calculus, only one parameter allowed. If you need more, then curry them. Okay. Make a curry out of it. Okay. So this is the second parameter. Okay. LT is called. Okay. So let's examine this LT. Okay. LT is actually the second parameter, and its type is this: T comma T arrow boolean. Okay. What is T? T is the type of object inside the list. Okay. So it takes two items of type T, okay, or objects of type T, and returns a true or false. Okay. And it'll actually do the LT stands for less than. Okay. So it'll actually compare T, the first object with the second object, and if first object is less than the second object, then boolean true will be there, otherwise it'll be false. Okay. Got it? So that's this. So we have actually parameterized and made it a function value. Okay, the comparison. All right. So if you say LT of x and y, x comma y, it'll work. Okay. So it'll compare x and y, and it'll be true if x is less than y. Okay. And what is the output of this merge sort function? It's a list of T, right? And then equals, and then it's this block. Okay. And the reason for the block is the same as before. We had to calculate the midway point. Okay. X equals n equals xs dot length over 2, and if n equals 0, that means it's a single item list or an empty list. The answer is xs. We are done. Okay. Else we have a block. Okay. So this is the more general case when you had two or more items. Okay. Now notice that we want to. This is something interesting. You can actually define functions inside functions, okay, and that's what is happening here. So we are actually defining the merge function inside the merge, and that too not right in the beginning of the merge sort. It is only in the else case, okay. So because that's where it's needed, right? So this is something it may not be very common or not possible in Java and other languages, okay. But in functional languages, this is allowed because a function is nothing but a variable, right? A value. Okay, so if you can define values, you can define values anywhere you want. Okay, why not here? Okay, so merge is a value. Okay, merge is the name of a function which is defined here. Def merge, and then it ends here. So this highlighted part. Okay, so let's look at this merge. Okay, now merge takes xs and ys. Okay, and returns the merged list. Now merge needs the LT. Correct? We said that LT is needed. But because merge is defined inside merge sort, this LT is automatically available inside. Okay, so that's the good part about defining this function inside. If you define this merge outside the merge sort, then there'll be a problem because then you have to provide LT to that as well. See, so that's why it's good to define merge inside here. And this merge is exactly the same as what we had before. Okay, also probably since we put that into one line, we put it this way. Okay. And also it's the merge to version, you see, with xs ys match. Okay, so it's the better version. Okay, and also this I put this in the one line. Okay. Oh, by the way, you probably want to copy those. Remember, we fixed this for the nil comma nil nil, right? So that's the one case, and then if it is nil ys. And this is y colon yt, right? And this is xt, and then xt colon yt. Y colon yt is ys, right? So this is the version we wrote, and also we put this whole thing into one line. Okay. Now the only difference between that one and this one here is that instead of saying x less than y, we had to say LT x comma y. Why? Because we don't know how to compare, right? We don't know how to compare two objects of type T, but we are given the function to compare two objects of type t. Okay, the LT is given to us, so we can just say LT x comma y, and that will return a Boolean value. Okay. Now, what is LT? That will be when you call merge sort, we'll have to provide that, and we'll see that in a second. Okay. And then this is outside the merge. This is just to split into, and then the final answer is merge of this one. Okay. So this is a much more cleaner version and also more generic version of the merge sort. Okay, so here's a list 5432 and another list. Okay, oranges, apples, and bananas. Okay, X's and fruit. And the first merge sort call sorts the numbers X's. Okay, list of numbers, but we had to provide a second parameter, right? The LT. So in this case, LT is it's a function which takes two numbers x, or two numbers, yeah, in this case two integers x and y, and returns x less than y. Okay, x less than y will be the less than comparison of x and y. Okay, and in the fruit example, this is a list of oranges, apples, so list of strings. So we had to provide a comparison of strings. Okay, now maybe there is a less than available, but suppose less than is not available on strings, then the function will be x comma y is the parameters x and y, and so this is the anonymous function without a name. Okay, and the output is x dot compare to y less than 0, right? So a compare to is a comparison on strings. Actually, it's the same as in Java. Scala also has a comparison of strings, and it provides an index less than 0, equals 0, greater than 0. If they are less, then the number is less than 0. If they're equal, they'll be 0. If it's greater than, it'll be greater than 0. Okay. So this particular Boolean function is the function you have to provide as a second parameter for fruit, so that it sorts it out. Okay. So you can see when I run this cell, I get the sorted list 2, 3, 4, 5, and also the sorted list of fruits there. Okay. All right. So we are done with the merge and merge sort. Okay. Next topic is quite important in functional programming. Okay. Higher order functions for lists. Now there are 3 or 4, actually 4 built-in higher order functions for lists, which are very, very useful. Okay, very, very useful. So it's important to learn these and start using them well. Okay, for 2 reasons. One is that they are very powerful. They can solve many problems. Second is they also make the code very compact. Okay, so and these are the 3 categories. One is called the map function. Okay. By the way, this map is different than the dictionary map. Okay. So although we will study both maps, this map is a higher order function for list processing. Okay. And this is called the map and the reduce. If you have heard of map reduce paradigm, exactly comes from here. Okay. So what does map do? Map, what it does, it takes a list. Now, by the way, all these functions, map, filter, reduce, and fold, there are 4 functions we're going to learn, higher order functions. What they do is they take a list as input, and then they take something else as input, and then transform the list, okay, in different ways. Okay, the map, what it does is it takes each item in the list and transforms it, and creates a new list with a transformed element. Okay. And how do you transform it? That is a second parameter to the map. Okay, so the map will take 2 parameters. One is a list, and other is how to transform each element in the list. Okay, and it'll perform that transformation on each item in the list, and then the output will all be stringed together into a new list, and that will be the answer. Okay, that's the purpose of map. The purpose of filter is it'll take, again, a filter also takes 2, okay, 2 parameters, the list and then a predicate, okay, which is nothing but a Boolean function. Okay, a predicate is nothing but a Boolean function. So predicate is also a function, by the way. Okay, yeah, this side a function, but the output is a Boolean value. Okay, so the second parameter filter takes is a predicate. Okay, and what this does, as the name suggests, it will go through each item in the list, and then whichever item satisfies the predicate, it keeps it, and whichever one does not satisfy the predicate, it throws away. Okay, and then creates a subset of the items in the list. Okay, so it's like filtering. Okay, so it filters the list based on a predicate. Okay, so this also is a list transformation, right? The map is a list transformation. By the way, in a map, the size of the input list and the size of the output list must be exactly same. Why? Because each item in the input list is transformed in a particular way to the output, okay, in the output. So that's why the size doesn't change. In a filter, the size will change, and in practice, it will obviously become smaller because here we are filtering items. We are throwing some items away, right? And the third, reduce and fold. There are two versions of reduce. One is called reduce and the other called fold. They are very, very similar. So if you understand one, the second one is about the same, okay? Reduce / fold, okay? And that, what it does is that it takes, again, some kind of a function. Obviously, it also takes a list. All three take a list as input, and then each of them takes a second parameter, which is a function in the first case. Second case, it's a predicate. In the reduce, it's a function. It's a function which does not transform a single item, but it takes two items and okay, I just got interrupted, so I paused the recording. So I'm back on the recording. Map takes a list and a function, okay, and operates a function on each item. Filter takes a list and a predicate, and it operates a predicate on each item and filters them. And the reduce takes a function, and what it does is that it's a function which operates on two items in the list, okay, not one item like the map, okay, and it combines two items into one item, okay, and this it does successively on every. So it takes the first two items, combines them into one item, and then that item it takes and combines with the third item, and then you get one item, and then and so on. So it reduces the whole list into one item, okay? So that's called the reduce operation. You see, combining all the items into one and making it one item. So the output of a reduce and fold would be just a single item, okay? So that's how these three higher order functions work, okay? All right. Maybe this is a good time to stop because I'm hitting the 32-minute mark, okay? So we'll come back into, this one is going into 4 or 5 videos, but that's okay, okay? A little bit more materials to cover. So we'll do a map, filter, reduce, and fold in the next lecture, okay? Hopefully only one more lecture. Okay, take care.